Okay, now in this video, Hermson recaps all the combinations and all that stuff, permutations, factorials, all that. Student council must have a representative from each class. We have 1 freshman, 45 sophomores, 51 juniors, and 48 seniors. How many possible combinations of representatives could we have? So I'm picking one of each group. So picking out of each group. I'm picking one. So I've got 54 freshmen. I can pick one, so no power, times 45 times 51 times 48. Okay, so 5,948,640. Okay, pretty easy there. Now, there are 5 people in a competition of pie eating. How many first through 5th place finishes are possible? So we have 5. We are going to take 1st through 5th, so all the places. So that is 5 all places. So that's simply 5 factorial. You take 5 times 4 times 3 times 2 times 1, and that gives you 120. Okay, now there are 20 people in a spelling bee. Awards are given for 1st, 2nd, and 3rd. How many 1st, 2nd, 3rd place finishes are possible? So we have 20. We take 3. And I do care about their places. It says 1st, 2nd, and 3rd, so I do care about their places. So that's the permutation, 20, 3, and 17. So I don't use the 3 on a permutation. I want those places, but I need to cancel out the 17 places. So 20 times 19 times 18 times 17, the 17s cancel. And I just find the product of 20, 19, and 18. 6,840 places possible. Okay, there are 30 students in a class. 4 will be selected to take place in a survey. How many possible combinations of students can take the survey? So I have 30, and I'm taking 4. But they're not placed, okay? It doesn't say 1st, 2nd, 3rd, 4th, okay? So not placed. So that will not be using the permutation. That'll be using the combination 30, 4, and 26. Now, I don't cross out anything because I don't want to place any of them. So both the people I don't pick need to be not placed, and the people I do pick not placed. So 30 times 29 times 28 times 27 times 26. 26 is canceled. 4 times 3 times 2 times 1. So parentheses 30 times 29 times 28 times 27. Close it. Divided by parentheses 4 by 3 by 2 by 1. 27,405. Okay, now we're going to play some cards. How many possible 5-card hands can be dealt from a standard deck of cards? Now, we've found that out. Just write that down. You don't need to recreate the combination. 960. Okay, how many ways can I be dealt 5 face cards from a deck of cards? There are 12 face cards from a deck, so I'm using a C, and I only need 1 because it's 5 of the same kind of thing. Okay, so 5. Now, how many face cards are there in the deck? Well, Jack, Queen, King, Jack, Queen, King, Jack, Queen, King, Jack, Queen, Queen. There's 12. So there'd be 7 left that I wouldn't pick. Now, I used all of them. Okay, so I number the 12 down till it's at 7. The 7s cancel. And 5, 4, 3, 2, 1. And those are products, okay? So parentheses 12 times 11 times 10 times 9 times 8. Stop, parenthesize, divided by 5, 4, 3, 2, 1. 792. Okay, so the probability, I take the total number of hands in a deck of cards, divide by that, and there's 792 of those hands, so that's pretty rare if you think about it. 792 divided by 2598960 times 100. So you have to go out to the hundredths place, 0.03%. Okay, how many possible ways can I be dealt 5 of the same face card? There are 8 total of any particular face card, okay? No, I don't want to do this problem, okay? Yeah. Okay, at a fast food restaurant, you get your choice of 20 sandwiches, 4 types of sides, 8 types of soft drinks. How many possible combinations of meals we can rate? So we're picking one from each group. Okay, so 20, if you're picking 2, they'd be to the power, but they're not. Okay. Okay, I multiply that, 640. Okay, in a 7-person competition, how many first through 7th place finishes are possible? Okay, so I have 7, and I'm going to take all places. Okay. Okay, so 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. 5,040. Okay, there are 50 people in a free throw shooting contest. How many first through 4th place orders of finish are possible? Okay, so I have 50, but I'm only going to take 4, and I see 1st and 4th, so that means I must be care about their places. Okay, so that's the permutation. So 54 and 46. So I cross that out and we use those. So 50 and 46. 50 times 49 times 48 times 47 times 46. The 46 is cancel. And then 50 times 49 times 48 times 47. And that's going to be 5,527,200. Okay, and then there are 20 people in my class. I need to pick 4 students to go to a math P. How many combinations of students could I pick? So I have 20. And I'm going to take 4, but I don't see words first, second, third, fourth. I don't see any of those words. So I don't care about their places. I put not placed. So I don't want to use the permutation. I want to use the combination. So not placed means don't use P. 24 and 16. So 20 factorial and then 16 and 4. So 20 times 19 times 18 times 17 times 16. 4, 3, 2, 1. Parenthesize those. And 20 times 19 times 18 times 17. Close it and divide by the 4, the 3, the 2, and the 1. Close it. 4,845. Okay, and then I'll do a card problem and then stop. So, possible 5 card hands. I want you to drill that in your head. How many ways can we be dealt 5 hearts from a deck of cards? There's 12 hearts in the deck. So I'm being dealt 5 of the same thing. Okay, so only 1 C is needed because I just put a 5. But there's 13 of those to draw from. Okay. So 13, and then 8 and 5. So 13 times 12 times 11 times 10 times 9 times 8. 8's cancel, and then 5, 4, 3, 2, 1. Okay, you do the math on that, it's 1,287. And then to find the probability, I know there's 2,005 2,598,960 hands, and 1,287 can contain 5 hearts. So 1287 divided by 2,598,960 times 100, 0.05% odds. Very small, but that is the statistically correct. Okay. All right. Next one. Okay, now this one here, it says how many ways to be dealt all red cards. So that means 5 red cards. Okay. Some games where color matters, I don't know. I just kind of had to think of a new problem.